guys, I'm Ahmet Dolma and today I'm gonna talk about my 599 project, which is image captioning project actually for you know it's like that you upload or select the image and the program gives you the generic text for what's happening in the image and describe it to you with some certain captions. So let's begin with our first project. Okay, let's start with our project here. To to start the application, you have to write python terrain.py from the terminal. So as it is seen in the below part terminal, you can see that it started to train the first epoch. It will create as many as we like when we set this parameter here, number of epochs. So what does this code do actually? It first transforms the images into uh, it transforms images into actually it first resizes the images to 256 pixel because when we feed some data into a model, as long as I understood from the concept, we cannot give the model raw data. So we have to transform it to our liking. Actually, not our liking, but there's a standard with it. So the model we use actually ResNet. So to train this model, we sorry, this is not the case. We have to transform the images before making it loading it to the model. This part this part actually does get the data from the Flickr data set. I downloaded it before. It's like this one, and the captions are like it will open. They are like this. Okay, what does this do? It actually checks is if GPU accelerator is ready to use, and as you can see, it is ready. It took a lot of time to configure that one. You have to download CUDA, and it should be compatible with your PyTorch version, etc., etc. Okay, these are our hyperparameters. First one is embed size. Actually, it represents the embedding vectors. I won't dig into that much of a detail because I don't know the deepest way of understanding it. But I know that increasing the embedding size increases the computational cost. But it actually, if you increase that, it also gives opportunity to the model to learn more complex relationships. Again, hidden size is like this is the total number of unique words that the model can handle. Okay, the vocab size it's vocab size is the total number of unique words. I'm sorry for that too. And hidden size is something like long-term memory network. This is a part of decoder. We have it here. So actually, embed size is here too. So number of layers. So number of layers is one. Actually, we could increase it, but the computational cost was really too big for my computer. And learning rate, actually, you can predict what it is. It's the step size the optimizer take during each update of the model's parameters. So a smaller value like this one 1 times 10 to the power of -6 It actually shows us to, it really gives us the results in a slower but more stable learning. I sometimes changed it to get more accurate results, but it didn't work. Probably my model or something was wrong, but I couldn't understand what was it. So what does this do? It actually writes summary to do runs section. So our application just cracked. So we have to just copy and paste some work we did before. So we have to remove the runs. This was our first epoch, the saved model here, but I'm gonna delete it so I can do it from start. So let's start again, and I hope that before this demo it can show us some results. So basically the important parts were there. So what does this do for each epoch? Run this script and train the model, calculate the loss. After calculating the loss, just save the model with the epoch name. So let's look at the training models. So let's start with the encoder. We use a pre-trained ResNet 50 model, which is a powerful conventional neural network. So its job is to process input images and extract high-level features. To find this tune for our task, we replace ResNet's final layer with a fully connected layer that embeds these features in the lower dimensional space. Uh, Actually, these embeddings is what gets passed to the decoder. So next, sorry, the decoder is an LSTM based RNN which generates captions word by word. It takes two inputs and it processes this sequence and maintains a hidden state of the capture, vice versa. I didn't really understand what it does, but uh, but I thought it is like a storyteller. It takes the features from the image and turns them into caption, one word at a time. Uh, okay, and lastly to CNN to RNN. Actually, this just combines the encoder and decoder together. Encoder CNN extracts image features, and decoder RNN takes these features and generates a sequence of words as the caption. So, what are the other things here? This is utils file. Actually, after this epoch is done, it will just generate some examples of the images like this pedestrian here or child here. It will just generate some things for them, and we can manually compare the results with the predefined captions by humans, who is me. I defined them. So what other things we have? We have getLoader here. GetLoader method. Actually, this file is sorry. This is for another thing. This file is all about preparing the data for the model to process. It handles like tasks like reading captions, loading images, and turning text into numbers the model can understand. We have vocabulary class. Think of the vocabulary class as a dictionary builder. It scans all of the captions and keeps track of how often each word appears, and if a word appears enough times, it gets added to the vocabulary. So each word is assigned a unique number, and it can also convert a sentence into a list of numbers using this mapping. So this is the Flickr dataset class, and this class actually represents our dataset of images and captions. It reads the captions file and the folder containing images. It also builds the vocabulary. Okay, we have my collate class. Um, Actually, my collate just does that. Images are grouped in a single batch. I don't know any detail about it. Further detail, sorry. So we also have a get loader function, which this is like a constructor of the data preparation pipeline. It uses the Flickr dataset class to load the data, and it creates a data loader to fetch data in batches, shuffle it, and handle parallel processing. Okay, we will see the results soon enough, but this was the the codes I used for, Flickr dataset. I used Flickr dataset for this purpose, but I also used, I think that it was here. I also used Coco caption dataset uh, to train the model, because the first model, as you will see soon enough, uh, got stuck on some captions and didn't generate right results. But when I tried Coca datasets, like I tried other Flickr dataset, there was a problem with this too. It used, it showed zero data loss, which is almost impossible for a image captioning model. So I couldn't understand what was the cause of it. So what changed here? Actually, the the only thing major change here, is the captions file in Coco dataset are kept as a JSON file. So we have to you know revise our get loader method. So okay, and the last thing I did was, actually, after two failures, I used Bleed Processor to, I used a trained model, and I tried to, you know, generate what could have been done with our models. And as you can see, by the way, our model using Flickr dataset generated some captions, but it only said whatever. I don't know, but it always kept writing the same things. Whatever. I wrote it in my report. So to keep it short, I will just run this code, and I will show you some images of pedestrians walking across the way. So this code just uh, takes the blip image captioning model, it processes it and gives you a caption. Like it says a photography of a group people crossing a street on crosswalk. Let's check another one. Okay, like, let's change it here. Run it again. Okay, now it shows a photography of a street with cars and a red light. So we could have done this, but uh, actually it was not enough. Thank you for listening. Have a good day.